Welcome to one of our final show and tell sessions. This one is really focused around transitioning local energy systems. I'll be hosting it for this morning. My name is David Richardson. I'm Head of Innovation for the Strategic Innovation Fund at Innovate UK. If we could just skip on to the next slide. And next one. So just to give a quick run through of the subject matter area that we're working on today and the agenda. So as the title of the session implies, we're really looking at local approaches to energy decarbonisation today. The scale of that locality does differ between some of the projects, but you'll find out a little bit more about them in a very short period of time. This is an area which is really quite close to my heart. At Innovate UK, over the last 4 years or so, we've delivered a program called Prospering from the Energy Revolution, which was really looking at smart local energy systems and how do we take a local, digitally driven approach to decarbonising energy vectors across heat, power and transport in a really integrated way. And actually, we've got some alumni from that program who've moved on to SIF projects and start to scale these up and really focus in on the energy network aspect of the problem with us this morning. So we've got 5 presentations this morning. We'll be starting with the Tyseley Environmental Enterprise District, which is an energy hub on the edge of Birmingham, which is looking at multi-vector approaches to decarbonisation, before moving on to planning regional infrastructure in a digital environment, which is really looking at decarbonisation options across electricity distribution and transmission. Before moving on to Northern Power Grid, who will be presenting on Inform, which is more focused on non-domestic decarbonisation. Finally, well, penultimately, Powering Wales Renewably. As the name implies, that is really looking at Wales as a locality and how you can unlock connections by looking at things from a whole system perspective. And finally, we'll be finishing up with Leon, which the program that I just mentioned, Prospering from the Energy Revolution, Project Leo, which you might be familiar with, Local Energy Oxfordshire, was a real success and poster story from that program. And we'll be hearing about the next iteration of that and where it's moved on to. If you've got any questions, please do put them in the Q&A box. We will have a Q&A session at the end of every presentation. You can use the chat function to introduce yourselves, share any links, talk between participants, but please try and put the Q&As in the Q&A box because it makes it much easier for us to track and ensure that we've covered them all. So, with no further ado, I'll hand over to the Tyseley team, and I think we've got Tom and Grant presenting. So over to you.
Thank you, David. If we're just waiting for the slide to come up. Okay, thank you very much. My name is Tom Notman. I'm the project manager for the SIF project on Tyseley, and I'll be taking you through some of the background to the project, the geography, and then handing over to my my colleague Grant, who will take you through some of the detail and the data requirements that we've been looking at. So just before we go through the introduction for this, I'd like you to bear 3 things in mind about the TEED project, as it's called, for Tyseley Environmental Enterprise District. That is, firstly, that this project really is about exploring how we do net zero locally in a very compact local environment. What does it mean for the companies and the residents in that area, and how do you make it work? How do you decarbonise an energy system in the real world? Second point is that Tyseley already has, through the energy park, a very high number of energy vectors that already exist. A real diversity of energy sources in a very compact area, so they're already there. And the third point is that we have a local community that is already very much aware of the challenge and is very keen to support the transition. So these are 3 factors for Tyseley that I think is worth bearing in mind right from the start. Could I have the next slide, please? So the agenda today, just to take you through a quick introduction, the problem statement, and then on to how we actually approach the project and how we built the data model, and then ultimately ending with considerations for where we go from here. Next slide, please. And again. So the TEED project is very much about finding a low carbon solution with low waste, recycling and renewable solutions within a compact area. The TEED zone itself is a very compact 2.5 square kilometre area of East Birmingham, comprising a real mixed environment that you'll see in a minute, of commercial and residential housing, circa 250 businesses with 2,000 plus homes of varying types and construction. It's also identified in the Birmingham Development Plan as a key part of one of the decarbonisation zones for Birmingham City Council, and part of their ambition to meet net zero by 2035. Very much looking at the wider kind of range of low waste pathways, as well as low decarbonising and low energy pathways. The TEED zone itself is also home to the Tyseley Energy Park, which hosts, as I said earlier on, a wide range of energy sources, from energy from waste, biogeneration, PV, hydrogen, hydrogen production on site, and clean fuel production. So there's a highly diverse range of energy assets and use cases, all contained in a very compact area. And that's why we've got the strapline here that this is probably the best location for a net zero living lab in the UK. If you're going to start anywhere to pull a number of disparate pathways together and put them together to find a low carbon solution, then you'll be hard pressed to find a better location than Tyseley. Go to the next slide, please. Just to see what that looks like, this graphic shows the kind of makeup of the area. You can see the grey buildings from the OS plot and the red boundary for the TEED zone. The yellow is the commercial area. So there's a lot of commercial industrial activity on this area with a lot of heat demand. And there is in the purple areas, you can see the residential areas that surround it. And these are the kind of edge areas for on into wider housing estates and on into much of the larger Birmingham conurbation. Next slide, please. To get a better feel for this, though, we've got a 3D model which shows the kind of in detail the kind of fabric and the kind of scale of the area. You can see there the energy from waste plant in the foreground, as well as the biogeneration plant, and as well as the hydrogen plant. But you'll see around the outskirts, you'll see a lot of that housing area that I was referring to earlier on. A lot of it is densely packed housing from sort of 30s, 40s, 50s through. So there is a wide diversity of housing stock on site, and it has a very substantial industrial area which has got a predictable heat load and a lot of predictable electricity and heat demand on site. Could I have the next slide, please? So the project itself is made up of 8 partners from National Grid, University of Birmingham, Equans, Pinnacle, SSE. The TEP partnership itself, the local energy park, is very much part of that. And they have already had significant stakeholder engagement on this. But one of the things that does really sort of stand out about this area is you've got a lot of the assets in place, a lot of the kind of potential here. What it really needs is a plan and a number of gaps filling to be able to pull it together, to be able to say you've got a whole system, low carbon approach for this area, and something that functionally delivers a lower carbon result than we currently have at the moment. It is worth bearing in mind that the energy from waste plant that's there is part of already carbon mitigation strategy from Birmingham City Council, that they're removing waste pathways from landfill. So incineration is a lower carbon, and more environmentally friendly approach than landfill, but it's only part of the journey. It obviously has to move on from there to be able to capture the carbon and do something with that. But the key factor in the energy from waste plant is at the moment that the energy that it produces, the heat that it produces, is wasted. And that is something that is been key to this project. Could we have the next slide, please? So the problem statement for the project is twofold. Next slide, please. We've got two distinct aspects to it. The first on the left is the TEED project approach itself. And that is really to find a low carbon solution using the energy vectors I've mentioned already, to say, how do we bring them together to create a low cost, low carbon solution to be able to move on to steps 1, 2, 3 of an energy transition. We're not looking at building final solutions. This is not about a 2050 enduring solution. This is about a transitional solution that will be step 1, might be the next 5 years, step 2, the following 5 years, step 3, the 5 years after that. It is very much a transition. And in the energy transition, it's key to remember that you have to start from where you are, which sounds obvious, but there's no point in starting with a kind of clean sheet of paper when you have an existing landscape with use cases, and the built environment has been well established for many centuries in the case of Tyseley. So the first part of the project is looking at how do we bring all that together to get an optimized solution to say, actually, with a number of interventions here, you can pull this together and create a complete whole systems low carbon solution for Tyseley. The wider ask of the project is to then say, well, how do you take that learning and how do you take all of the work that we've done in Tyseley and you turn that into a movable plan, a plan that effectively creates a template for other parts of the UK, which have similar or even even more diverse energy vectors that you're trying to bring together. There's definitely a methodology that we've started to build on this, that you can see there's challenges that will be generic wherever you go in the country, albeit the local aspects of it will be different, whether you're in Cambridge, Glasgow, East Anglia or Cardiff. But crucially, we are bringing both of these together with an overarching kind of ambition here, which is, as I mentioned already, we have a energy from waste plant, which is just venting heat to atmosphere. And that's a resource, it's an asset that the local environment and the city has, which is just being wasted. And we're looking to be able to see how we can harness that and give it back to the local community in a positive, low carbon, low cost way. The next slide, please. So just pictorially, this is a schematic showing exactly what you've just seen in that 3D model, but just graphically showing that the different use cases for property and the different use cases for end user occupation of those properties, as well as the different models that are there. All of the vectors exist just now in some shape, size or form, but they are all discretely siloed broadly along the lines of the current kind of market structures. And there are certain things which make it very difficult to bring these things together. Particularly when you get onto anything that can be referred to as storage, it starts to cross the line. So one thing that is very key, keen focus for the whole project is we're starting with a demand profile here and working back. So if you start with demand and work back, you come up with a fundamentally different approach to if you're starting with an infrastructure build to build a energy system that covers the whole area. So we're starting with demand, working backwards, looking at how we can bring these together locally to be in the most efficient and effective way. Next slide, please. So what have we done thus far? Well, next slide again. You'll all be familiar, or most of you will be familiar with the kind of structure of the SIF projects. We've got the similar 5 work package structure from use case definition through to reports and the alpha application for the next stage. The ones that I want to pick out here particularly is the optioneering and the art of the possible in the middle, because that's where this project has really come to the fore and really started to sort of create some challenges and some possible ideas that make it a compelling project to take forward. Could we have the next slide, please? So in detail, what this looks like is it starts with the existing infrastructure. As I said before, you've got to start with where you are. We have the siloed existing infrastructure at the moment from electricity and gas, which is supplying this area. and we're challenging ourselves, looking at, well, what happens if you're actually going to take the gas supply network out of this area and not rely on natural gas? How would you do that, and what would be the option? And that starts from, well, you can electrify heat, and then you look at the infrastructure costs of being able to do that and reinforcement costs. So what alternatives have we got to be able to mitigate that? We've also been looking at the market and regulatory structures to say, well, we've got to examine the challenges in the regulatory governance, both now and in the future. We do know that in 2050 that the existing regulatory framework won't exist in its current form exactly the way it is just now, but nobody has actually sort of penciled that in yet. So we've got to start imagining what we need to be able to transition from where we are today to that kind of end state, to be able to make use of these assets. Fundamentally, we're looking to use the currently wasted energy. There is a significant amount of energy that is wasted, somewhere between 80 and 100 gigawatts per annum of heat is lost to the atmosphere, and that is clearly enough to help us with the challenge of providing heat to the local area businesses and residential properties. We've been modelling the built environment. You've seen a bit of our fabric built environment 3D model at the beginning there that gives you an idea of its kind of the fabric and structure of the buildings, the heights and the volumes, which Grant will go into more detail of in a minute. But fundamentally, it's about understanding what the demand side is and how we actually supply that demand. Reducing emissions, fundamental to everything that we're doing here, and looking at how we can actually make the biggest impact over the next 5, 10 and 15 years. But crucially, this last point, breaking silos, the adoption of the whole system approach has really been one of the really interesting parts of this whole project. How you bring them together, how you bring batteries into play, how you bring heat storage into play, and how you actually make use of them in the day-to-day lives of the businesses and communities in the area. And that is presenting some very interesting areas of future study. Could we have the next slide, please? There we go. So crucially, the bit that's missing from the Tyseley area at the moment is a heat network. If we're going to use this wasted heat, we need some way of being able to harness that and provide that in a usable form around the area of Tyseley to the various domestic properties and the commercial businesses within it. So there's a lot of work in both understanding the load, the heat requirement, and the use profiles. So a lot of it is into time of use and how we actually can make best use of that energy, because clearly we have to match the supply and demand curves locally, and where possible be able to level out peaks and be able to avoid them entirely. So for the next section of this project, for this presentation rather, I'd like to hand over to my colleague Grant, who will take you through the work we've done on the data side. Grant, over to you.
Thanks, Tom. Next slide, please. And then the next slide again, please. So this is building upon additional learning effectively from previous projects that was mentioned earlier in terms of the PIFR projects. An ongoing challenge localized energy systems at all is the data availability to build and evidence various trade-offs. And in many cases, the data is simply unavailable in a level of detail that's required. So the project, because it was a discovery phase, we focused more on annual level data rather than looking at half-hourly data, but I'll come to that in our slides later. We were fortunate enough to get heat network zoning pilot data that was made available to the project partway through the discovery phase, and thanks to the Department of Energy on that. That had very helpfully annual heat demand and peak heat demand for many of the 2,000 plus buildings within the TEED area. Thanks also to Ordnance Survey for organising appropriate licenses at short notice, which allowed us to use master map polygon data for building footprints, the height data, as well as address-based premium to look at building categorization as well. So that was really quite an interesting journey. Two, the alpha phase will focus on 30-minute synthetic data sets to be used for flexibility analysis, and that's in addition to peak and annual energy analysis, and we'll come on to why 30-minute is needed for that. Next slide, please. So the annual data gives a high-level energy flow assessment or Sankey diagram, and building up from various sources a picture of the energy supply and demand of the TEED area, and that's shown on the chart on the right. It's a non-trivial task even to do this, which one would think would be a reasonably sort of straightforward thing to do, not only in terms of matching data sets or a lack of available data, or actually an uncertainty in terms of an approach as well. So an example of that would be, at the moment, how do you allocate the amount of primary energy in terms of liquid fuels for transport demand within the area? Because EV demand in the future, one might expect charging of electric vehicles within the area, that is going to add to the primary energy or requirement of energy demand. So does one approach that at the moment to try and emulate, what is the primary energy demand for transport at the moment? So we had some really quite interesting approaches and differences to try and do that, but we landed on a particular approach for that. Next slide, please. One of the things that came out fairly clearly is the need for highlighting the need for a building stock model, but not just for Tyseley, it's 2,000 plus buildings, but also scalable right across different areas as well. That would help analysis across multi-vectors, not just for the demand for heat, but the classification of building volumes is a challenge, particularly for multi-use buildings. There's a number of multi-use buildings within the TEED area, some quite large buildings in there, but it doesn't have necessarily residential sort of blocks of flats with multi-use on various lower floors. It doesn't have that type of building terribly much. But the blending of data sets, it did show some differences in the data, incomplete data in others. And it just, further pointed to the fact that appropriate data of good quality for local energy systems analysis continues to be a challenge. And this is common, I believe, across many innovation projects. Next slide, please. So one of the things we were looking at in terms of, as an example of the type of flexibility that can be undertaken with 30-minute data is, this is shown as a low duration chart of measured data of a single primary electrical substation in National Grid electrical distributions area. It shows a number of interesting features, such as the headroom between the stated firm capacity of the substation, that's 23.6 MVA as a firm capacity, as the dotted red line at the top, and the peak demand shown over to the left-hand side of the chart. And that headroom is the gap between them. Another feature is the sharp increase in this low duration curve, again on the left-hand side of the chart, and a vertical line showing the level of highest electrical demand values for 1% of the year. In essence, adding additional electrical load at those times, such as from EV charging in the future or heat demand, would reduce that amount of headroom and eventually add to the need for additional capacity in that infrastructure, and therefore add to additional cost effectively. And next slide, please. But another way of looking at it, this is just the same data, but it shows the electrical demand data plotted in a typical manner against the time, with the upper chart showing the highest demand week in the data set and the lower chart showing the lowest demand week in the data set. The blue area is the measured substation demand, whereas the orange area is a calculated sort of valley fill, just to get a sense of how big it is in comparison to the actual blue demand as well. And that's between 10 o'clock at night and 7 o'clock the following morning. The TEED area highlights challenges around these types of data. The boundary of TEED, and this is common again with other projects, it doesn't neatly match against measured electrical service area data. So it might be measured, but it doesn't naturally fall across the actual area of interest. And therefore, this recurring challenge with local area energy analysis points to the creation of synthetic data to try and overcome this problem. Next slide, please. So one of the things we've started to do, but this is further down in terms of alpha phase, is using the stock model and categorization data, and also what's called the Faraday tool by the Centre of Net Zero, which is the research arm linked to Octopus Energy. to create a bottom-up electrical demand profile for domestic electricity. Some of the, I'll talk through the chart in a moment, but this would require a similar sort of approach for domestic gas using other data sets and a validation of synthetic electrical and gas demand with measured data. However, and this is particularly for the TEED area, for a highly industrial commercial area such as TEED, there are major challenges around data sets for non-domestic energy demand and sub-daily profiles. So just very quickly talking through the chart, the blue line was the synthetic data from a bottom-up analysis that we did on one of the feeders, effectively, looking at how many residential properties of particular types that there were in that particular feeder area. And then the orange line is the measured data from NGED for that particular period of time. So that's quite interesting. Certainly, it seems broadly similar, and that gives us some hope that synthetic data using that tool could be quite an interesting approach. Next slide, please.
Just a couple of minutes more in, Grant.
So very quickly, good data has a cost and therefore it needs resourced. There is a cost to the increased digitalization of the energy system and ongoing curation and production of good quality data assets. And I think I'll skip to the last point in that slide. There is therefore a tension between the resourcing and creation and curation of high quality data, but yet making that data available to at low cost, a wider group of stakeholders. So data is key to evidencing the different trade-offs in energy planning. And I'll hand back to Tom.
Okay, thanks, Grant. Could you have the next slide, please? And again. So unlocking net zero delivery, what does all this mean? Well, I mentioned earlier on that we've got the energy waste plant there that is already a mitigation, which has got its own development path as well to reduce greenhouse gas emissions. We've got potential to capture between 80 to 110 gigawatts a year of usable heat, channel that into a network that could provide water source heat and storage for the TEED area. Once built, the net zero transition options to export heat more widely become much more overt, and the TEED area is surrounded by housing and further parts of the wider Birmingham conurbation. And there's an immediate benefit there to the local electricity grid for offsetting the potential for significant reinforcement to electrify domestic heat and some of the industrial heat. Next slide, please. And again, so very quickly in conclusion, our considerations for Alpha. This project has certainly highlighted just how diverse the energy vectors are within the TEED area and what the options are. There's a hugely rich area of decarbonisation opportunities that spring from this, starting with filling in the gap on a heat network and then building from that onto wider decarbonisation ambitions on fuels and hydrogen production. We need more data, as Grant's alluded to. We need to create a detailed design feasibility options for the next stage and propose local market design proposals. The one at the bottom there, create a virtual DSO, local coordination model. There's a lot of talk about local coordination and how this all comes together in the local environment. One of the ambitions that we would have for the next phase is look practically at how that might work in an area such as this with this many different vectors. Last slide, please. With that goes more modelling of the infrastructure transition, more detail on the reinforcement requirement and offset. That is definitely something that's key to this, but that needs us to be able to understand the flex feasibility on that and how much flex is going to take a role in being able to mitigate that. Demand side flexibility and use of battery storage as well as heat storage is fundamental to one of the many solutions in this project. And we want to take forward the existing collaboration partners to develop a single option and conceptual design in Alpha, which is bringing Birmingham City Council into the project as a more formal partner, along with perhaps Cadent Gas and Ordnance Survey, and a number of buildings retrofit consultancies to look at the fabric options on some of the larger buildings and mixed-use buildings that Grant was alluding to. So we think it's a great project for the future, as a huge opportunity, and as a local community that is hungry for change. So with that, I'll conclude the presentation. Can we go to the next slide, please? And open it up for questions. Thank you very much.
Thanks, Tom and Grant. We're running a little bit behind here, so we do have a few questions really looking around the economics and costs of doing this, and one on how fuel poor and more vulnerable consumers are impacted. But given time, if you are able to look at them in the Q&A box and answer them, and we'll have to move on to the next presentation. So if we could skip on to the next slide. We've now got Jenny and team, and one more. Jenny Woodruff and the team who've been working on planning regional infrastructure in a digital environment, or PRIDE. Over to you, Jenny.
Thank you, David. Morning, everyone. Yes, so PRIDE, Planning Regional Infrastructure in a Digital Environment, is looking to see how we can use a digital platform to share information to make sure that our decision making for regional infrastructure is optimised. Can you move on to the next slide, please? And again. Great. So today we'll quickly go through some introductions before looking at the problem that PRIDE was trying to address, a respective review of the work that's been done, and then looking again to the alpha phase. Next slide, please. And again. So I'm Jenny Woodruff. I work for National Grid Electricity Distribution, and I was one of the original team kicking off the PRIDE project. I'm also joined today by Stuart Fowler from National Grid ESO, from West Midlands Combined Authority, we've got Kate and Eleanor, and from Advanced Infrastructure Technologies, we've got Christopher Jackson. Next slide, please. At this point, I'll hand over to Kate.
Great. Thanks, Jenny, and hi, everyone. So the problem that we are trying to address with the PRIDE project is that we know that we need a radical shift in the level of low carbon technology deployment to reach our net zero goals. But at the moment, that rollout is hampered by market uncertainty. We, as a team, have identified that local area energy planning, or LAEP, as an unhelpful acronym, as a tool to helping us to reduce market uncertainty. And it does that in a number of ways. So we're looking to kind of bring together and overlay both national and locally held data sets. It helps us to build the business case for locally led initiatives. And you just heard about the TEED project, for example, which can then help catalyse kind of wider market rollout. And then we want to also take it full circle and use local area energy planning to help us to mitigate for some of the remaining infrastructure barriers by providing evidence to feed back into things like the DFES and FES planning functions to help us to influence future energy investment in the networks to make sure it's going in the right place at the right time. So that's great. But there's a further problem. Local area energy planning as a process is really helpful, and in fact it's been endorsed by Department for Energy Security and Net Zero, and we put it in our Trailblazing Devolution deal. We think it's a really good thing to be doing. But at the end of the process, if you end up with a static plan, you can't ask that plan questions such as, what if the rollout of solar is faster than you expected? We know that, this has happened in the past and it's tripped us up. Or what if we were to be granted powers to designate heat network zones, for example, which would fundamentally change the way that people kind of decarbonise heat in a certain area. If your plan doesn't account for that when you've done your plan and it's a static plan, then it really does kind of derail you in terms of what you need to do next. So what we then look to do, or lend to see if we could utilise digital tools to help us carry out some of the processes of local area energy planning, whilst remaining a dynamic reflection of the changing energy landscape. What do we mean by that? Well, we wanted to see if developing a prototype data platform to help us visualize and contextualize some of these multiple data sets, that we could achieve many of the aims of the local area energy planning process. So in the discovery phase for this project, we had the advantage because we took some really rich data sets, well over 100, that were developed as part of a previous Innovate UK project called RESO, Regional Energy System Operator, which David has alluded to. It's from the Innovate UK sponsored project. And in that project, we looked at the city of Coventry, and we were able to gather a vast amount of data. And we're able to pull a lot of those data sets into a tool to be able to kind of interrogate it, to be able to look into it in much more detail. We also ran a number of workshops and gathered a lot more data, really, to develop a large range of potential use cases that could be supported by that tool. We looked at the organisational and governance structures that might be needed to ensure the data sits at the centre of energy investment decisions for the city. In Alpha, when looking to develop that further by deep diving into a subset of those use cases, as well as continuing to develop the governance design alongside national regulatory changes that we may expect to come down the line, such as the potential introduction for the Regional System Plan or RSP, and prepare for a full-scale trial in beta ready for rollout. And I'm going to hand over to Christopher to talk about how this project sits at the intersection of a number of initiatives which are looking to redefine the planning of our future energy system to reach net zero.
Thanks, Kate. So it's worth taking a moment, next slide, please. So it's worth taking a moment to understand how this project is innovative and how it sits within the innovation landscape of other projects. This Venn diagram on the right shows 3 areas of innovation which have been active in recent years. So first of all, starting in the top right circle is interoperability and standards. So in round 1 of the CIFs, there were 2 projects that explored this theme, and they were the ESO's virtual energy system and Southern Gas Network's gas system of the future digital twin. And both of these projects identified over 30 use cases for digital twins and favoured the development of an ecosystem of digital twins that would be deployed for each use case and that would be interoperable with each other. Also, both projects independently identified the local area energy planning use case as being particularly worthy. In the bottom circle are projects that explored organisational and governance and non-technical barriers to place-based net zero transitions. Both RESO and Accelerating Net Zero Delivery identified over £81 billion of benefits to locally planned and optimised energy transitions. And in the top right, there have been a number of projects that use digital tools to accelerate aspects of local area energy planning, such as Project EPIC, Project RESOP, and Project Clio. What's unique about this project is that it combines all 3 innovation areas and explores in a deep dive the use case of digital tools to enable local area energy planning. Next slide, please. So as part of this project, we deployed the prototype of the digital tool on the Coventry city area. As Kate mentioned, Coventry holds over 100 data sets that are valuable, that are of value for local area energy planning, but decision-making officers lack the skills to visualize and interpret the data. So key data sets were visualized on the tool for Coventry Council users, and user research was undertaken as to how the tool performed. I'll now pass over to Eleanor, who will take us through the learnings from each of the 3 work packages.
Go for the next slide, please. And one more. Thank you. So yeah, I'm going to start by showing what we've discovered during the discovery phase of CIF, starting with work package 2, just to try and set out some of the, I guess, organisational issues, which was also sort of alluded to in the TEED project. So essentially, we've got sort of a map, and it's showing the network kind of operator or provider areas for Severn Trent Water, Cadent, for the West Midlands block, National Grid, ED for the West Midlands and East Midlands, and then we've kind of overlaid the local authority areas for the WMCA, as well as the kind of LEP areas and the Midlands Net Zero Hub, just to sort of explain what that means. So we sort of know that alignment between administrative and physical boundaries of infrastructure providers and local authorities would be critical in most effectively designing and developing these local area energy plans, and then successfully achieving local decarbonisation, and particularly kind of decarbonising those major assets. However, kind of the reality is that that alignment and actually sort of changing those physical boundaries would be incredibly difficult and would require some sort of major restructuring. So what we're looking to do as part of this work package in Pride is looking at the different organisational options and structures that could be considered in order to overcome those boundaries and those sort of difficulties in a way that isn't a restructuring. So in terms of using the digital tool, we hope that using that tool with the further innovations, we can essentially kind of overcome the boundaries by kind of having a visual data layer that sits above that, and it will provide a technical solution to, sort of the boundaries that exist as they are. I'll pass back over to Christopher, I think.
Thanks. Next slide, please. So in this work package, we mapped and valued sub-use cases that describe in more detail the overarching local area energy planning use case identified in previous SIF projects. And we mapped 17 use cases that we have clustered into 4 benefit groups, depending upon the user group to which those benefits occur. So from left to right, the first benefit group are local authorities, and these 6 use cases focus on reducing organisational barriers between the different levels of local government and other institutions to improve access to data. So these include creating decarbonisation scenarios, unlocking finance with more robust revenue projections and business cases, and includes a digital stakeholder engagement and democratization of decision making, monitoring and reporting against progress towards net zero, and support for data-driven and evidence-based grant applications. The second benefit group is the private sector, and these 6 use cases focus on reducing project development costs through more timely access to data and analytical tools to make faster decisions about where and where not to cite low carbon technologies. And the range of technologies include renewable generation, building energy efficiency, electric vehicle infrastructure, energy storage, and renewable heating. And the third benefit group are energy networks, and these use cases focus on self-service tools for new connection requests and reducing the workload experienced by particularly electricity networks responding to new connection requests. Secondly, digital workflows to submit to support distribution network operators' new ED2 requirement to support local authority energy planning activity. And thirdly, forecasting future customer demand to better align with strategic investment. Now, on the next slide, please. We explored a number of ways in which we could prioritize these use cases. And on the chart on the right-hand side, we've mapped the use cases by risk and reward. So the highest reward and lowest risk is kind of green in the bottom right, and the lowest reward and highest risk is red on the top left. So if we cluster the use cases by the benefit groups described previously, we can see that local authority benefits are the easiest to address and the largest benefit, followed by a private sector benefits group as the second. And we've shortlisted the use cases for 3 use cases for alpha phase development, being renewable heating, electric vehicle infrastructure deployment, and optioneering and zoning. Next slide, please. So work package 3 explored what data sets are required to achieve each use cases. And we explored what the data model linking the use cases should be. And we explored how to align the project with the ESO's of virtual energy systems learnings. And this slide summarizes a similar point that I think was just made by Project TEED, in that building stock and individual building stock data is very important to the delivery of local energy systems, and we would agree with that. But what we're trying to highlight in this chart is that there is what we describe as a strategic delivery barrier between a top-down strategic plans and projections in the form of future energy scenarios and DFESs, and bottom-up local area energy plans. And the challenge is if a local authority institution wants to use a DFES or as a FES as part of their strategy, what they're missing is the building level data that projection was made upon. And we call this the delivery gap, because although local authorities may know generally where to deploy a technology, they don't know on which building. And the reason being is that most of the local area energy planning and the other forecasting that has occurred before has been done at a unit of resolution of an LSOA of 1,000 or more houses. And you really do hit that dotted line when you try and move from a zone of 1,000 houses to, well, which house in particular. And that's the problem of that descending arrow on the left-hand side. So what we're proposing is a change to the modelling approach with the arrow on the right-hand side, where there is no aggregation to LSOA, and that the underlying building level data is passed through between all different levels of modelling. And we think that's an important change to make in the modelling approaches at all three levels in the energy transition, whether that be at transmission, at distribution, or at the local level. That's the main sort of learning from work package 3 that we wanted to underline. I think I now pass back to the next speaker.
Just a 1-minute warning.
We have the next slide, please.
I think it's going to be me, isn't it? Yeah, so before, I think Jenny just talks about alpha. I thought it was just useful just to explain why ESO is involved in Pride. And I think Kate and Eleanor have both articulated that, you know, if we're going to meet net zero, we need to think differently. And the same applies to us. So if you accept that local area planning needs to include energy, then as we move away from National Grid to become FSO next year, it means that we're going to have to think differently about what we do as a business, as well as what that also means for GB. And so therefore, I think Pride offers us a unique opportunity to learn about what local area energy planning might look like, you know, what that means in terms of the capabilities that we might need to acquire, new data streams and all of that, but being cognizant of place, because I think as Kate has mentioned before, place will be, you know, a vital consideration for us. And then hopefully we can then repurpose the learning from Pride and apply it to GB. And then I think I hand back to Jenny, don't I?
Yes, next slide, please. So just to round off, we see the alpha phase as having two main work streams. One to do with the development of the digital platform to enhance the features relating to those three selected use cases. We'll do some deep dive workshops to make sure that we're selecting the enhancements that make the most sense for people, and then go through the normal process of development and testing before using local authority staff to test the enhancements that are made and suggest improvements for the beta phase project. On the other side, the organisational trial development, we've got a proposed organisational structure that we want to test out. It would be fantastic if we had enough staff to actually have 2 teams working in parallel, one working the old way, one working the new way, but that's not likely to happen. We're going to have to work out how we can simulate the key elements of a particular way of working, a particular organisation in that trial phase that's planned for the beta part of the project. So who participates, how, where, when, and what those preparation activities need to be. We're looking at Coventry as a test area, and we've already done some importing of their data, and that's looking very, very encouraging. So that wraps it up for today.
Brilliant. Thank you all very much for a very comprehensive presentation. I've got one quick question that we'll try and fit in. From your perspective of, you're looking by the sounds of it at how responsibilities for different institutions and actors might shift, but not necessarily looking at whether new institutions themselves are required. Is that within the scope, and is there a reason that you've decided that that's not the route to go down?
We have tried to reflect what we think will happen with the shift to the regional planner role and also the FSO role, to see how that would shape an optimal organisation that will be able to deliver local planning most effectively.
I think the other half of that question is that there is going to have to be some fundamental governance shifts from the kind of from the democratic accountable bodies, the local government, you know, the local authorities, the combined authorities that feed into that local planning piece, and that is actually a big factor of what we've been looking at thus far. So how do we within our own organizations help to speak a shared language that we can then build the evidence base together and be able to have those informed decisions? And that's also a big change from a kind of local government point of view as well. So I think we have to look at kind of both sides of the coin in that respect.
I think also, David, I think that, you know, there's a level of uncertainty about where some of this stuff sits now anyway, and I think it's about, for me anyway, it's about learning by doing and just finding out, you know, what's the optimal way to make this happen. You know, because I think, as I said, and I think Kate said, you know, this is challenging enough as it is, without having to factor in the fact that, you know, we've got to engage however many million people in the UK.
Yeah, brilliant. Thank you very much. And I'm all on board for learning through doing, so we can plan so far, but in the end, we just have to get on with the job. So we'll move on to the next project now, which is led by Northern Power Grid, but also with participation from EA Technology and the Energy Systems Catapult. So if I can hand over to Chris Goodhand and team. Thomas, are you taking the lead?
Yeah, sure. Hi everyone, Thomas Stone from EA Technology here. If you could flick to the next slide, please. So today we'll run through our Inform Show and Tell. So quick agenda, Chris will give us a quick introduction to why we have done the Inform project discovery, and then Marcus will give us an overview of the stakeholder engagement that we carried out through the discovery phase of the project. I will then run through an example user's journey of the software tool that we're envisaging developing, followed by an assessment of the benefits before we take any questions. So without further ado, Chris, I'll hand over to Chris to give us a quick introduction to the project.
Okay, I will attempt to be very brief. If I can have the next slide, please. And probably the next one. There we go. So this, in a nutshell, is the problem we've actually got. If you have an existing site and if you have a site that you're attempting to decarbonise and connect to our network, the process that you have to go through is repetitive, and it is quite an expensive process for you to go through. And effectively, the decision point in that process about the connection and whether you can still meet your business case and what have you comes late in that process, which effectively sends you back to the beginning. So it's very much snakes and ladders, we seem to spend quite a lot of time coming down the snake. So if we want to enable people in a much easier manner to be able to connect their decarbonising sites to us, we thought that this process really does have to be rethought through. So what we see here on the top is the current process as we understand it, and the inform process, the new process that we intend to use, is shown below. So moving very much from a proposer does a lot of the work and then engages us relatively late in the process and gets an answer that they may or may not like, to something that allows them to very much self-serve and allows the processes to move very much quicker, which hopefully gets more low carbon sites connected to our network very, very much faster. So we've worked on this with EA Technology and the Energy Systems Catapult over the last 3 months. And I think Thomas will now start to talk you through more of the detail.
Yes, thanks, Chris. That's great. If we can have the next slide, please. Yeah, so throughout the discovery phase, we did stakeholder engagement, and I'll pass over to Marcus to take us through a summary of our findings from that engagement. Here's Marcus there.
I suggest you take it, Thomas.
So Energy Systems Catapult led on stakeholder engagement with a range of stakeholders. So these were typically complex site owners. So these included local authorities, councils, NHS estates, Ministry of Justice, and so on. So from a range of public and private sector organisations. What we found was that the public sector is very reliant on grant funding for heat electrification, and that's often tied to particular grant schemes which typically have like limited lifetimes for that they must spend their money by. So the timeline for connection is important, as well as the cost of the connection. And currently they're reliant on a relationship with the DNO to get information about connection costs. And often this is done through consultancies or other middlemen. The main issues that we found were the ability to get costs from DNOs for projects quickly and fast. Timelines for connections from schemes such as the public sector decarbonisation scheme often ended up being sent back because the timeline and/or budget for obtaining a connection is too high or too long, and there's nothing available on HV connections. So the key outputs was interested in having a scoping stage to capture costs and timings. The tool can also provide more detailed output based on further input. So these are things such as the optioneering approaches to give alternative non-firm connection options for reducing connection costs or timelines. And we developed a user journey that was played back to stakeholders with a range of options to then refine that user journey, which I'll present now. So if I can, the next slide, please. And again. So in a first workshop, we gathered gathered thoughts from stakeholders about the functionality they would require from a tool and what data they had as inputs. And that was refined and then developed into an initial set of user journeys, which was played back to stakeholders at the second stakeholder engagement event for their feedback, which we gathered and then refined the user journeys to produce a final set. And this is an example of one user journey. So you can see here, this is our first input page. On this information input page, we have some general information. And then we have information about the location of connections. So a direct input from stakeholders was they wanted different ways of entering the meter position, either latitude, longitude, or a postcode entry. So that's included there. We also understood from stakeholders that many stakeholders wishing to decarbonise their heating would have already done some initial work understanding what their additional electrical demand would be. So we have a checkbox here to kind of tick or cross whether that's understood. And in this user journey, the user knows that. But if they don't, then the tool will estimate that for them. We also take some energy efficiency outputs, inputs to help understand whether energy efficiency can reduce connection capacity cost by reducing the required connection capacity of connection required. Next slide, please. So here we've got information required from the user, half-hourly existing electricity demand profile for all their normal uses of electricity, and then an additional column for their forecast additional electricity demand on a half-hourly basis. And then this data can be used to understand whether flexible connections, on-site storage, etc., can potentially offer them reduced timelines for connection or reduced cost of the connection. If the user has crossed the box on the previous page saying they don't know what their existing electrical demand, their additional electrical demand due to electrified heating will be, then this tool will estimate that for them based on data inputs on their existing fossil fuel system. This page also takes in data about LCTs on the site, so EVs and any photovoltaics installed. Next page, please. So mapping page, this is a simple page just for the user to confirm where their meter position is based on their input, and then the tool will automate a connection route to the network. Next slide, please. Now, once all those inputs are taken, Inform will go away and process the request, and within a matter of seconds, we'll produce an output page. And on the output page, there will be an estimated cost of connection, an estimated timeline for connection, and then various options for flexible connections or other alternative connections, such as by using on-site storage or energy efficiency, to potentially reduce either the timeline or the cost or both for obtaining a connection. Next slide, please. So alongside this, we did a piece looking at the benefits from developing such a software tool. And this is looking at if we develop this tool for both Northern Power Grid license areas. So there's some uncertainties here. So we've done some sensitivity analysis, and which suggests that the total network savings per year by 2028 could range from about £1 million to £13 million, with the most likely somewhere around £6 million. And that's split between benefits for the site developer and avoided social line network reinforcement as well, after the significant code review came into place on the 1st of April this year. So yeah, this offers savings to both the site developer and the network operator. Next slide, please. We've also assessed the network planner time savings. So the forecast number of HV budget estimates is expected to ramp up pretty fast over the next few years as sites increasingly look to decarbonise. And it's expected to ramp up to about 3,000 days of network planner time savings by having this automated self-serve connection tool in place by 2028. Next slide, please. Now, at the moment, for HV budget estimates, site developers would be charged a fixed rate per HV budget estimate processed. And because Inform will be an online tool that's free to use, these charges will be avoided. offering direct savings for site developers, and that's forecast to total about £1.2 million per year by 2028. Next slide, please. So what are the cost savings to site developers through electrification of heat? This plot shows what the anticipated savings are of switching from gas boilers to ground source heat pumps, with the orange line there looking at that switch, and then also the effective energy efficiency. So the grey line is the aggregate cost savings through switching to heat pumps and installing energy efficiency to reduce heat demand. Next slide, please. And then this slide shows some of the carbon savings. So we're talking something in the region of 350,000 tonnes CO2 equivalent per year by 2028 in enabling switching from gas boilers to heat pumps, with a further up to 50,000 tonnes per year through energy efficiency to reduce heat demand. Next slide, please. And again. So what are our future activities and next steps? So at alpha stage, the concept is to develop a proof of concept software development, a piece of software across a small area of Northern Power Grid's license area for some specific sites, and use that proof of concept software to demonstrate the optioneering functionality, which is the real innovative area here, looking at how we can automatically tell users how flexible connections or on-site energy storage, for example, could potentially be used to either decrease the timescales until they can get a connection, or decrease the cost of a connection. And then looking further ahead, it's anticipated that we will build this tool out fully across all of Northern Power Grid's license area, such that anyone, any HV site looking to decarbonise in Northern Power Grid's license area can use the tool, which will be hosted on Northern Power Grid's website. That brings me to the end of our presentation. I'd like to open up for questions.
Thanks a lot, Tom. Very well done for stepping in and taking on the other parts of the presentation as well. I've got a couple of questions myself, if I can.
Sure.
Right, I really like to see the project because, in fact, it maps closely to some of the Round 3 Strategic Innovation Fund challenges as well, which are looking at improving network planning and coordination, but also provision of flexibility to decarbonise heat. One thing I was wondering is, rather than only looking on a site basis, could this tool potentially in future enable coordination between different sites as well? So it might be that actually one site is suitable for large scale storage and another can't because it's space constrained or whatever. But at the moment, there's no way for those two parties to communicate or have visibility of connection applications.
Yeah, there's certainly potential for something like that. It's something the stakeholders actually kind of were keen for. There are potential, we have concerns with data privacy on that, so we'd have to think quite carefully about how we could do that, complying to all data privacy requirements. But that's certainly something we would be interested in developing in this tool.
Mm-hmm. Perhaps something as part of the application process of, would you be happy with this data being shared with parties on a consented basis or something? Mm-hmm.
Yeah, I think David, that comes down to when you explain to people that one of the routes to actually getting the sorts of connections they want is to sort of participate in that data sharing. I think they do tend to be a little bit more open to those sorts of things. That they quite often the issue is around being careful not to share commercial data. That's what gets people itchy sometimes. But more often the information around the sort of the networks and the sort of technical content is a bit of an easier sell. But I think we have a trend increasingly with all of the processes that we have, rather than trying to automate them as they are, very much as with Inform, we've had taken a view, well, how can you effectively re-engineer this process into something new that actually allows us to go forward. And I think perhaps some of the attitudes that people actually have are also going to have to move as well. But you know, any technology is being done in some sort of socio-economic environment, and quite often if one thing changes a little, some of the others are going to have to change around it to accommodate that.
Mm-hmm. And when you were doing your stakeholder engagement, did you have any interest from third-party intermediaries who would like to play the role of we can advise on what assets you might benefit from being cited, that sort of thing?
This is where I would refer to Marcus. I think there was maybe one or two, but it was mostly direct engagement with site owners, councils, hospitals, etc.
And that, to be fair, is very much where this has been pitched. It's been pitched at our sort of the councils, the NHS, two representatives as part of the project. You know, Ministry of Justice, military sites, anything like that. Mostly sort of public sector types, I think, is what we actually had in mind. Doesn't mean that there isn't the option there to expand this slightly, but you know, it's generally on the sort of the bilateral relationships rather than through a second or third party at the moment.
Mm-hmm. Do you think there's anything intrinsically that makes it sensible to prioritize public sector organizations? Is it just because they're looking for a break even rather than large commercial opportunity?
Yeah, I think they're amongst those we have a little difficulty with, quite frankly, because of the nature of the way their funding arrives, the fact that the process as it currently stands is expensive, repetitive, and uncertain in terms of you getting effectively a late outcome from us, makes it particularly difficult for people funded in that particular way. So that's been very much in our thinking. Doesn't mean that certainly doesn't mean it can't be used for others, but the key motivation really was understanding that that particular aspect of the funding streams that the public bodies are particularly exposed to.
Got it. Brilliant. Well, thank you very much. We're going to take a short break now for about 10 minutes, and we'll come back at 11:55 for the final two presentations, which is a quick reminder of the Power in Wales Renewably and Leon projects. So see you back in about 8 minutes or so. We've now got the final two projects in the transition in local energy systems show and tell. The first step is Power in Wales Renewably, and then we'll be moving on to the final project with Leon. And I will finish up the session by just giving you a bit of information about what else is going on in the Strategic Innovation Fund at the moment, and other ways that you might want to get involved in round 3 and beyond. But for now, I'll hand over to the Power in Wales Renewably team. Simon?
Yeah, thanks, Dave. I think it's Sean, actually. I think, Sean, you're going to lead off?
Maybe we can give Sean just a moment. He might be rejoining. Are you there, Sean? with time and consideration, Simon, maybe if
Yeah,
Rich
it's all good.
could take the lead.
Yeah, if you could move on to the next slide then, please. Thank you very much. So, yeah, Powering Wales Renewably is a project led by National Grid ESO. Hopefully Sean will join shortly, who's the project lead for this, and as part of the virtual energy system, we're closely aligned with that program of work within the ESO. The other partners are National Grid Electricity Distribution, National Grid Transmission, CGI, and also the Welsh Government. The presenters today will be Sean from the ESO, Rich Hampshire from CGI, and myself, Simon Brown, who leads the Smart Grid team at CGI. Next slide, please. So Powering Wales Renewably, one of the key areas that this project looks to address, I think, is to address some of the Welsh Government's ambitious decarbonisation plans. So we're looking to identify and evaluate potential use for flexibility, but also align with the local area energy plans and the Welsh Government's decarbonisation plans, with the aim of increasing renewable electricity hosting capacity, and also delivering the net zero transition for the Welsh citizens and their communities. So if we move on to the next slide, I'll pass over to Rich Hampshire, my colleague, who will take through the overview of the project. Rich, you there?
I am indeed. Thanks, Simon. As Simon said, I'm Rich Hampshire from CGI, and through the foundation phase, I've had the privilege of facilitating the stakeholder engagement workshops. Powering Wales Renewably addresses the SIF Round 2, Challenge 2, preparing for a net zero power system. As well as the ESO, who are leading this project, Powering Wales Renewably involves the Welsh Government, who, as well as bringing together the different interests across the Welsh Government itself, they've provided access to representatives of key stakeholders from across the electricity system user communities. These included developers, investors, and representatives from community groups. To complete coverage of the whole electricity system value chain, the project partners included National Grid Electricity Transmission and electricity distribution. The objectives of Powering Wales Renewably is to provide visibility across the whole electricity transmission and distribution system to help better inform decision taking. The output of this will be to provide a foundation that can be combined with other data sets to help different stakeholders to better inform their plans and, as I said, improve their strategic decision taking. Data sets that will be incrementally integrated into the digital twin that we'll be building through the different phases of this project will include existing reinforcement plans, local area energy plans, future energy scenarios, and distributed future energy scenarios, and the network location of distributed and customer energy resources. Powering Wales Renewably builds on and leverages the learning from previous innovation projects and the investment in the distribution integrated network model and the virtual energy system. Our approach has been use case driven. Use cases we used as the basis for the workshops that we held with project partners and with stakeholders throughout this discovery phase. Stakeholder input about what they value and what they would find useful has been used to refine the use cases and prioritize what we will do in the alpha and subsequent beta phases. The project delivers the first use case at scale for the virtual energy system and is set in the context of the whole electricity system and is based on the inclusion of stakeholders from across the system value chain. Next slide, please. In terms of our approach through this discovery phase, our activity has been very much stakeholder led. We held 13 workshops and individual interviews to identify our stakeholders' priorities. This process involved 25 different individuals from across the stakeholder organisations, partners, and the different groups involved. Whilst our initial view and preferences was to do these as workshops, given the challenging timescale, we had to adapt and run smaller sessions and individual interviews to getting into people's diaries. This ensured that we were able to get input from our target stakeholders. We initially ran a series of bilateral workshops or interviews with partner organisations. The Welsh Government, as part of their contribution to this project, facilitated engagement with not just their own internal stakeholders, but representatives from community groups and the investor and developer communities. We ran bilateral workshops first to better understand the perspectives of the different stakeholder communities. This input then enabled us to facilitate a series of multilateral workshops where we brought different stakeholders together in a constructive way to surface their different issues, open up their different perspectives to each other, and to promote discussion of what was needed to accelerate the Welsh Government's decarbonisation plans. Through this approach, we've identified and achieved an agreed consensus on priorities. Based on the roles of the people involved and working with the partners and stakeholders, we've identified 18 different personas of people with varying interests and responsibilities and who can benefit from the Powering Wales Renewably solution. These personas have helped us to look at the challenges we're addressing from their different perspectives. The output from each stage has formed the input to the next stage. Additionally, we've conducted a desktop review to identify relevant projects, the learning from which we can incorporate and build upon. Ultimately, based on what was identified as important by the stakeholders, we've prioritised outputs for the alpha and beta phases and developed our delivery plan and approach for alpha. Next slide, please. I've already mentioned that based on the roles and responsibilities of those participating in our workshops and interviews, we were able to identify 18 distinct personas based on their respective interests. Clearly, it'd be impossible to cover all of these in a 15-minute show and tell, but we've grouped them under each of the primary partners, along with some of their prioritised wants and needs. To highlight just a few of those priorities, for the Welsh Government, these included better visibility that would help inform policy action and community engagement. From the system user perspective, priorities included being able to identify potential locations and improve time and cost to connection. For the ESO, priorities included improved whole system coordination and resource utilisation, and also better visibility of embedded generation at the distribution level and how that could lead to impacts at the transmission level. For the transmission network operator, it's all about strategic network design, and for the distribution network operator, it was all about prioritising reinforcements, better outage planning, and how flexibility could be used to better operate the distribution system. Next slide, please. So when you come to look at the stakeholder priorities and the associated benefits against the three overarching use cases we identified and originally took into the workshops, the foundation use case, integrating for the first time intelligent digital models of distribution and transmission networks to provide a digital twin of the combined T&D infrastructure, was identified as being of key importance. It was identified as providing the visibility needed to better inform decision taking. It will also provide a trusted basis and common understanding of the issues to promote discussion, objective discussion between stakeholders. It was seen as enabling areas with available network capacity to be identified and enable connections where required. The ultimate benefit is seen as reducing time to get a connection. For the second overarching use case, that of enabling the use of flexibility, the need to coordinate the use of flexibility between system users was the identified priority. This was seen as improving the opportunity for distributed and consumer energy resources to participate in the provision of flexibility services, hence improving market liquidity and revenues for service providers and consumers. The improved visibility of the location of assets with flexibility was identified as an opportunity to improve the management of constraints and ultimately increase the ability to host renewables. For the third of our high-level use cases, that around connections and capacity, the opportunity for the twin was seen as enabling improvements to outage planning, underpinning the delivery of local area energy plans, and providing the ability to model changes to the connection queues and identify interdependencies between the transmission and distribution networks. This is expected to accelerate delivery of decarbonisation and local energy plans, reduce the time to get a connection in the required location, and reduce the number and/or duration of outages, resulting in reduced disruption for consumers. Next slide, please. To provide an indication of some of the ways the discovery phase has helped us evolve our thinking, we started out by being very much focused on increasing the integration of renewable generation. Through the stakeholder workshops and interviews, the participants reminded us that that's just one side of the equation. It may seem obvious now, but identifying capacity to get decarbonised demand connected is equally important. This includes connections for loads like electrolyzers, if we want to expand our thinking to the whole energy system and not just the electricity system. Across all the partners, our lead contacts were able to get us access to people with the right experience and knowledge. Because of the short timescales, as I've already said, we had to adapt our preferred engagement approach to fit in with their calendars. And also, through the process, new contacts were identified through the workshop process, people who could bring additional input or additional insight in the areas we were interested in. One of perhaps the most surprising benefits was identifying the different system actor perspectives on the same underlying issues and the different problems that these created for them. We saw some light bulb moments from understanding things from each other's perspectives, a willingness to collaborate to solve these challenges through common interest. And that really helped us work through what to prioritise. The engagement enabled us to identify relevant data sets that we will need to access to help realisation of the benefits we're targeting. Also, the definition of whole system. We started to identify a number of areas in governance, such as in the codes, that may need to be modified to support a future system. And this helped us to develop and identify our learning outcomes from the next phases of this project. Above all, there was consensus across stakeholders that powering Wales Renewably will deliver something that can help accelerate delivery of decarbonisation objectives and action on climate. Simon, if you're still around, I'll hand back to you.
Thanks, Rich. I'm still here. So if you could move on to the next slide, please. We'll just finish off really with a look ahead towards to Alpha. So hopefully you'll agree it's an ambitious project from the scale and looking at addressing some of the challenges across the whole of Wales as a country, and how the digital twin that we're building can support those needs and that engagement. You know, based on the feedback from the stakeholder groups, we've tried to put some sort of principles around what we're looking to achieve in Alpha. So one of the key ones really, and what we want to do, is get a representation of the full Welsh electricity network within the first 2 months of the Alpha project. So my view is that this isn't, just a technology project. In fact, it's more about the people and the engagement of those stakeholders as we move through Alpha to inform the use cases that we're going to deliver in beta around connections and flexibility coordination. So we've taken an agile approach. We're looking to build then on top of the initial twin a number of demonstrated products which we will use through stakeholder workshops to get feedback and shape the real detail within those use cases and where we can make the most impact through the beta phase in those 2 areas. But the other key element of this, and I think we've heard from some of the other projects today as well, the data and access to data and consistent data is key to deliver the net zero transition. So we've got a dedicated collaboration stream within the Alpha phase to speak with other innovators, stakeholders and community groups and businesses on how, and using the virtual energy system team to reach out to see how the network for Wales that will develop within the twin can be used by other projects to address some of the other areas that will help us all get to net zero by 2050. So I think that's everything from the project. Thank you very much for your time today. I don't know, Sean, if you've made it. But I'll hand it back to you, David, I think, for your questions. Thanks very much.
Yeah, thanks a lot for that. We've got one question in the chat already, which is simply asking, could you offer some examples of the code changes that you think might be required? Who would like to take that?
So there was a number of areas that were identified around things like when things can be taken, reinforcement investment can be taken onto the RAB and how that drives revenues for the networks businesses. Obviously, Ofgems and the ESO are running processes around connection queue management at the moment as well to try and improve those, and the understanding of what's involved with getting a connection. I think this process can provide an evidential base that can help support some decision taking on it. So there's 2 examples in terms of codes and regulation that we will want to explore and potentially make recommendations on.
Brilliant, that's really helpful, Rich. Another question, and Jen, maybe you might be able to offer something on this as well, is there something particular about the Welsh archetype which means that this solution will be bespoke for it, or do you anticipate that actually when you get to the nub of the solution, it might be applicable everywhere equally?
Yeah, thanks, David. I don't believe that this will be bespoke to Wales. I believe that Wales is representative of the rest of the UK and regions very similar to Wales, where we've got both urban areas, rural areas, connections between the two. We have got areas that are very much off grid. And I think that the challenges, I think perhaps it's that we are in Wales facing perhaps some of the challenges around grid access slightly more soon than other areas, because we are slightly less well served with transmission grid in some areas. And that this, and perhaps also because of Wales's cooperative history. So collaboration is something that, we're practicing doing. And I think that whatever this project delivers, and we've heard multiple use cases, multiple potential outcomes that I think can help across the system and help all users. I expect these to be equally applicable across the rest of the GB system.
Mm-hmm. Brilliant. Yeah, so perhaps not unique, but experiencing things early and therefore being a good trial ground for it. Well, thank you all very much for the presentation. We'll move on to the final project now, but that was really comprehensive and interesting. So the final one is the Leon project. And I think we've got a whole host of presenters with us today for this. So who's going to start us off?
It's me starting us off, David. Can you hear me? It's Frank Clifton. I'm the
yeah, Frank, over to you.
Thank you. If you can move on to the next slide, please. And again, that would be great. And again, sorry. Aye, that's better. Super. Good afternoon. My name's Frank Clifton. I'm the Innovation Manager at Scottish and Southern Electricity Networks distribution business. And we've been working on Project Leon, which is an extension of Project Leo, taking it to the next stage. Project Local Energy Oxfordshire Neighbourhoods is what we've called it. And this is about accelerating the decarbonisation of energy demands and creating an enabling environment for homes, small business and communities to transition to net zero and at pace and at scale we need to achieve both Oxfordshire's and the wider country's net zero targets. In Project Leo, we implemented the Smart and Fair Neighbourhoods concept, where we actually implemented some net zero transition measures into small communities across Oxfordshire. And it was well received and produced benefits by the users. It showed benefits to the electricity network and the wider energy system. So what we want to do with Leon is take a systems innovation approach to develop the tools, commercial arrangements, and the local governance arrangements, which we mentioned a number of times today, to try and drive that transition at pace across the county to achieve implement the measures we need to do to actually let us achieve this net zero goal. So this is actually working at the secondary network level and the LV level, right at the grid edge, to try and implement that net zero transition at scale. So we're dealing with small communities, small groups of stakeholders, and trying to scale that across the whole of Oxfordshire. So I just want to pass on to my colleague Barbara, who will explain more about the project. Barbara.
Unmute. Thanks, Frank. Next slide, please. And the next one, thank you. So this slide shows pretty much where we got to with Project Leo. And where we're working from here is working back from the end result that we all need, which is a transitioned grid edge, which means that we have we transitioned to a renewably powered electricity system, but have only had to double the size of the networks in doing that. And in order to achieve that good outcome, we have to get everybody participating in helping to transition the grid edge. So in Leo, we understood that every household and business has to be flex ready, and that's what we call future fit. It's not just retrofit now, it's future fit. Those flex ready units then have to be enabled to work together in smart community energy schemes behind the secondary substation. And in order to help that happen, we have to have an enabling environment created that is governed by a local system that makes this possible. A partnership including the local network operator, the local authorities, local businesses and local communities. So this is really building on what we started in Leo in Oxfordshire. But we think that if we get this right in Oxfordshire, it will be able to scale right across the country. And we need to do this quickly because the networks recognise that they can't invest, even if they wanted to, and even if they wanted customers to pay for that, in tripling the size of the network that we'd otherwise have to do, because we don't have the time available. So at the grid edge, this is really the game in town. And at that point, I'll pass on to Malcolm for him to explain where we've got to in developing this thinking in the discovery stage.
Thanks, Barbara. Next slide, please. So this shows a little bit more in detail of how those different aspects fit together. I'd like to draw your attention to the bottom of the screen to start off with, which shows that there are 3 different scales that we're looking at. So from left to right, we're looking at kind of like the 5-year horizon is where typically bulk supply point and grid supply points planning process take that approximate length of time. Then the next one the next one along is the 2 to 4 year time horizon. So it's kind of like the decision-making process and implementation at the primary or HV level. And then at the 0 to 1 level, year time frame is more or less what the secondary transformers need to be adapted at. What's interesting is there's also a corresponding scale for the social scales associated with those electrical scales we'll discuss later. So if we start on the diagram from the left-hand side, we can see that one of the key things we need to be doing is bringing together the DNO planning process together with the local area plans and together with key stakeholders and key end users in the system. And that's the role of the local net zero coordinator, is to bring those together to make sure that we have strategic plans in place. The question is then, how do you translate that into local areas? And this is the role of the grid edge coordinator, which will be interfacing between those strategic plans and the implementation of both the future fit and the local smart community energy services or scarce services providers. And in those three need to be working together to make sure that the processes between them are all aligned to deliver the correct service. If you go to the next slide, please, and Timur.
Thank you. So obviously we need to show that the solutions we're developing and solutions we're proposing, they deliver benefit. And in order to achieve that, we looked at what the future might look like if we don't do anything. So we tried to establish a counterfactual between now and 2050. So looking at from the network perspective, looking at the household perspective as a customer, but also societal, what impact the societal level, but also environmental level. And then we looked at how the solutions that we've been talking about, the future fit, smart community energy scheme, and the local net zero coordinator, what benefits do they deliver at each of those levels, and trying to assess with the target of assessing, quantifying, and also deliver a qualitative benefit from each of those levels. So for example, as Barbara mentioned earlier, Future Fit can deliver a flex-ready solution, which brings in LCTs, but also energy efficiency, make it interoperable with the future energy system, and in a way that also supports the customers in a way of quality assurance, and also being comfortable that they are fit for the future. They know they don't have to then further invest anymore to be compatible with the future, with how the system develops. Whereas Smart Community Energy Scheme is looking at how can we optimize self-consumption of local generation, local flexibility, and local demand? How do we optimize all of that together, both at the household level, but also at the community level, which then brings quite a wide range of benefits, both the networks and the customer. So we're flattening the curve, we're flattening the peaks, and maximizing how much of energy, renewable energy, can be consumed within the local area. And finally, looking at the local net zero coordinator, which then you can see it's almost like a connecting point between the strategic plans and actually enabling local area energy plans and delivering those, enabling those benefits from LAPs. Collectively, across GB, we anticipate could achieve up to 90 billion savings between now and 2050, as well as additional carbon reduction. But we're looking to further develop those solutions and further quantify those values. Thank you. And I'll hand back over to Barbara.
Thanks, Timur. Next slide, please. And so just to summarize all of that, the discovery phase, we've really been building on Project Leo to become Leon, focusing on the neighborhood scale, right where we all live and work, where all the energy is used, in fact. And the size of the prize we're quite surprised at, which is, as Timur was saying, £90 billion, which is about 3 times more than we were expecting it to be. Second thing we've really understood is that this is systems innovation. It's not widgets that are put together in specific ways. It's how you create a system with positive feedback loops in terms of how people interact with it. which really operates right at that grassroots level where we all live and work, in a way that complements regional governance reform, but really takes that right down to where we all are. Complements the digital spine by, again, really taking that right to the LV level. Includes, therefore, a grid edge coordinator role, which is about helping communities and households to spot opportunities and then take them. And it's about the synergy between Project Leo and the Pioneer Places, Net Zero Pioneer Places project we've got going in Oxford called Future Fit One-Stop Shop, which is about how you deliver those future fit units that are so critical to the implementation of Leon. And then the third thing, which we think is really exciting, is understanding the investment engine that is the efficient use and timing alignment of investment at the very local level with investment in the network. So there's that annual drumbeat at the LV level, which really can drive the speed that we might transition the grid edge. And do that in a way that really helps the network operators to make their investment strategic, wise, efficient, and therefore best for all of us. And we can align our task programs together so that we can respond to that drumbeat to learn and succeed fast. So passing back to Frank.
Thanks, Barbara. If you just move on, please. Excuse me. So what have we done in this first discovery phase? There's four main areas you can see there. We've really, as Barbara said, we've taken that retrofit concept and developed this future fit model to make sure that the homes and the businesses are ready for the future. Future fit, as the name suggests. And we've developed two very detailed customer journeys for a domestic customer and a non-domestic customer. And that's, as we said, that's been delivered in collaboration with the Pathfinder project, FOSS project. We've taken the idea of those future fit units being part of a smart community energy scheme or service, a SCES, as we call it, and that's really building on what we've demonstrated in Leo and trying to put the arrangements in place to make those smart community energy schemes sustainable, both environmentally, but more as importantly, economically, so they can actually stand on their own 2 feet and continue to work. And that includes getting people to participate and stay and remain participating in them for the duration of for the long term. When it comes to the coordination and governance has been mentioned a lot this morning, which is reassuring. It's obviously a recognised issue. We see additional role for a grid edge coordinator to actually get involved in the delivery and the doing of this, to actually make it happen, take it off the page and bring it into reality in people's homes and streets. And we also fully recognise it's a change in landscape, so we need to make sure whatever we are doing here within this project dovetails with all the other work that's going on with regional system operator, local area energy planning, and our local authority partners, Oxford and Oxfordshire, are key to helping us make sure we're aligned with all the other work that's going on in the street. And as you can see, we're starting to develop a pretty detailed and rigorous CBA to try and assess the qualitative, quantitative benefits of this for the network, for wider society and the overall system in total. And it's producing some very, very encouraging results. So if you just move on, please. I'd just like to talk a wee bit more about what we're doing in Alpha. So if you could just go to the final slide, please, Anita, that'll be grand. So what we're going to do, we're going to continue to focus on those Leon pillars, developing the regulatory changes we need to enable some of these things to happen, particularly in the SCES field, developing some of the commercial models to allow SCESs to be implemented and developed and operated in the long term, some of the digital tools we need to let the information flow, the skills we need to enable future fit, and the supply chain we need to deliver all of these methods. But importantly, we need to make sure all of this works for all the different customers. So it's an inclusive approach. It's not restricted to people that can afford it. It's available to all to ensure a just transition. So that's really important for us. I think the other thing which has been really, really enlightening for the work we've been doing from Leo is this different approach to the various investment time horizons. So as Malcolm talked about earlier on, we do a lot, as a DNO, we do a lot of planning for the higher voltage networks. It's got a long lead time, takes a lot of planning, and we have dozens of grid supply points. We have probably hundreds of primary substations, but we have 100,000 secondaries in SSEN. If we've got to upgrade all of those and their associated LV networks, so there's probably 500,000 of those potentially, we need a much more agile and a completely different approach to managing them. So we tend to plan them 6-12 months ahead. And if we can get that in tune with what our stakeholders are doing, we can really, really accelerate and enhance that programme to deliver maximum benefits. And as Barbara says, actually do the investment in the right place at the right time, to avoid us doing it once and doing it right and making use of the capacity we create. And that bottom-up approach is going to bring benefits all the way up the system. But it needs to be agile, it needs to be swift, and it needs to be really, really smart how it does that to avoid us getting completely bogged down. And we're also going to spend a lot of time refining that benefit case and quantifying what we can do to demonstrate this, what can be achieved by having a locally based energy system, because ultimately it needs to involve the people that are going to be in the homes, etc. And we're obviously preparing for a beta trial. We will develop in detail potentially 2 real-life trials, and both in the hopefully in the SSEN area, but perhaps in a completely different geographic and economically sort of a different economically. The right words here, sorry, a completely different demographic from what we've used in Oxfordshire. Okay, so that's us finished. So we're happy to answer any questions and take on board any comments that anyone may have. Thank you, David.
Thanks a lot, Frank. You're not the only one who gets caught up on their words in these webinars.
Sorry, mate.
With some of the jargon we use.
Far too much.
We did have one question about what specific community assets will be used as part of the SCES. And Timo has already provided an answer that you're fairly agnostic to the type of community assets. Or
absolutely.
As long as it's the grid level.
Yep.
I've probably got a question which links to that a little bit, is with your investment work stream, which seems to be primarily focused on unlocking network investments, what's the strategy for enabling sort of equitable access to grid edge assets for lower income or those that don't have the financing to be able to do that? Is that the community aspect of this which unlocks that?
I'm tempted to let Barbara answer that.
Thanks, Frank. I unmuted in anticipation of that.
Good.
The focus should have come across actually as an interlocking investment, David. So thank you very much for asking the question. And so it's a combination of household and business investment behind the meter, community investment of generation assets, storage assets, and also new businesses to run the scares in front of the meter, and network investment to enable all of that, particularly secondary substation level monitoring and modelling. And the question about being inclusive and enabling everybody to take part in this is a really good one. And for me, that question is all about how you get the investment in behind the meter for each business building, each household and each business. And that's one of the questions that we've been looking at in the FOSS project in terms of the innovative financing models that might be available for that, which themselves need regulatory tweaks alongside the regulatory tweaks we need for the management of the network. So quite a lot of system innovation needed, but I think that, that inclusivity becomes behind the meter.
Yeah.
And allows you to take part in front of the meter.
But it's that whole suite of approaches that is required to really unlock it as well.
Aye, it's the joined up nature of what we're trying to do, David, and bring it all together in as agnostic a way as we can. In fact, it's not a contradiction.
And whilst you've mentioned some of the other projects, I was wondering if you could just give your perspectives on leveraging different funding routes and how you've managed that, good and bad, because one of the key objectives for us as a programme is to try and break down some of these silos and make it a little bit easier for people to navigate. Any advice or pitfalls to avoid?
It's well, I don't know. It's helpful, okay, and it's useful, and we've I think we've obviously got the FOSS project, but it brings itself some challenges because it introduces some uncertainty because they're on slightly different timelines and like. But I think we can work with that, and but should allow us to if successful, we can then deliver a lot more over and above what we have already. And I think we kind of managed that with Project Leo and the PIFA programme, and I think we're hoping to take that same philosophy going forward and get more out of this. I mean, Barbara, you're looking at the other end of the funding spectrum.
Yeah, that's right, Frank. I mean, I think as a consortium, we've always taken quite an aggressive approach to leveraging, if I can put it that way. You know, our own model at the Low Carbon Hub, we're run as a profit-making energy business, but our profit legally has to be used for community benefit. And every pound that we make in community benefit, we know we've leveraged 14 times. And that's the sort of approach that we're bringing into to Leon. And I think the sort of approach that Timo was taking into the counterfactual business modelling. So leveraging is a key word for the Leon Consortium.
Yeah, and perhaps when we do our evaluation, we'll have to do a bit of negotiation in with your other teams on who claims these ginormous benefits. Yeah, we'll probably have to split them, to be fair. Yeah, and just a note on that is, particularly as the projects start scaling through phases, if they're successful, I think we're open-minded to look at ways at which we make the monitoring and governance of these projects, which are coordinating different funding routes, as streamlined as possible, because we don't want to get bureaucracy in the way of the good, really. So thank you all very much for that presentation. That brings us to the end of today's show and tell. I've just got a couple more things to run over if you could skip on. So we've got our final show and tell, day 8, tomorrow, which will be really looking at supporting a robust delivery of net zero, which includes elements of resilience and supply chain rigor, etc. We will be publishing all the show and tells on our YouTube channel, so all those links will be provided, and the final registration is also here. If we could just skip on to the next slide. A reminder of some of our upcoming webinars. We've got a series which is really looking to target people who are new to the energy network innovation ecosystem, really to understand what the role of the energy networks is, what the policy and regulatory environment looks like, how you might be able to develop market access for third parties particularly, and then exploring some of the innovation support and funding, not just through the CIF, but alternative routes as well. Next slide. So this is the final slide, just to highlight some of the other routes that you can stay in touch with the Strategic Innovation Fund. We're always posting things on the website, but the best way to keep informed is usually through signing up to the newsletter. We tend to put out a once-a-month update on all the opportunities and updates across the programme. I mentioned the YouTube channel. We also have the Bright Spark podcast, and shortly we'll be releasing some podcasts on the round 3 challenges as well. But if you do have any questions or clarifications, do get in touch with us via the CIF_offgem@iuk.ukri.org email address. And that's all for now. Thank you all very much for joining, and I hope you have an excellent afternoon as well.